In this video, you are going to learn different type of sampling method and how that influence the concentrations. So from these pictures, you can see that sampling method could be a graph samples or it could be used by auto sampler. The difference is graph samples means you just directly collect from water using a bottles or your containers. You just put it there and get the samples. And that's not accurate, as you know that a lot of times the concentrations vary with time. So that's why you have to do the flow average or mass average, all that you have to do it, a time average. That's why it's useful to have an auto sampler like this, which is basically as a flow, there is a pump inside it, and it's just basically take water at different times and collect it so you can measure the concentration as average over time. So that's why it's important to understand that your choice of method, whether graph samples or auto sampler, can influence your concentrations. And auto sampler is more accurate because it's a composite samples, and whereas graph sample is just a snapshot. And also you have to know that where you take samples is very important. If you take sample very close to source, your concentration will be much higher. If you take the concentration very far from the source, it will become diluted. So that's why it's important to know the location matters where you collect samples. This near the influence, near the effluents. For instance, in a pond, you can measure the concentration right near the stormwater where it's mixing with the stormwater or is later. And sometimes you can see that from the drainage, you can put this pipe here and this pipe, you can draw water from it. And the other factor is the time is a factor. As you know that based on pollutograph, the concentrations of pollutants can change with time. Initially, it could be much higher if the pollutants are released very quickly, and later time is raining for a long time, then it become diluted. And so again, the antecedent conditions, whether it rained the day before or not, that also influence because every time it rained, it washed off some pollutants. So that's why when you take a sampling day, you should record all these numbers. You should record when time you collect the samples, how long it has been raining, and also if there is any antecedent rain happens the day before or many other days. So when is the last time it rained? So these are the factors is important when you explain your concentrations. And most of the time you can see that the pollutants peak will appear before the runoff peak or the peak flow will occur later than the peak of the pollutants. And the reason is the most of the pollutant dissolve very quickly, and so the concentrations become the concentration rise very rapidly compared to the water. As the more water comes, it becomes more diluted. So as basically source become depleted with time, and the same time the volume of water increases with time. So that means the peak of the pollutant will happens much before the peak of discharge because of less dilution effect. And so that's why a lot of times you might see that the pollutant peak appear a lot before. All right, so now that you know this one, the decision making that you have to think of is identify what type of pollutants you need to monitor so that you know what kind of sampling method you should use. Is this a composite sample, graph samples, and also even the choice of the containers that you are going to use. And then once you identify that, you have to also look at the conditions. Is this during rainfall? If it's during rainfall, what time after the rainfall? And what are the weather look like? That way you can explain your concentration later. Then identify the location. It is something near the inlet, outlet, where you are going to do it. Is this near the hotspot? And then at the end, you have to decide based on the resource you have, can you use the graph samples or auto samplers? Now that you know those things, sample handling is become more important. This is key because this will determine if the concentration change based on the choice of the sample, the container that you use. And so here I just explained few of the things that you have to think. All the container has to be pre-cleaned. Pre-clean means you have to use water so that there is no residual concentration from previous time sampling. So they have to be completely clean. And during stormwater sampling, it's good to use the same stormwater just to clean again so that there is no the wall is now equilibrium with the stormwater itself. So even you clean before, you could do that. Sometimes it's not required if it is perfectly clean and you're not worried about the wall itself absorbing any pollutants. So pre-clean container, sometimes pre-clean container means it's not just clean, it could be acidified. Acidified for metals. Because if you add a little bit acid, whenever you take the water, that acid will mix with water and makes the pH low. That makes the metals stay dissolved for a long time. So you may have to acidify it if you have to take the samples for the metals. If not, as soon as you collect, you spike a little bit of acid, high concentration of acid, so that it can stay dissolved. So this is important for the metals. For other, you just clean the clean the containers. And if you're looking for volatile pollutants, they are going to escape from water to the headspace. So that means you if you have any headspace means if you have a bottles like container like this and cap, you do not want water to be here. This is called headspace. In this headspace, the volatile pollutants will evaporate. So when you open the cap, it will escape. So that's why when you take samples for volatile pollutants, you have to completely submerge the container inside the water and cap it inside it so that there is no headspace remaining. That will prevent any kind of volatile pollutants to escape into the headspace of the air. Then you have to think of whether you should filter or not. Just think of what filter does and filter size. Most of the time, the filter size, the pore size is 0.45 micrometers. If you filter that, it removes a lot of particulates, it will remove bacteria. So when you are looking for dissolved pollutants, you should filter it. So think of dissolved pollutants. Let's say dissolve nitrogen, nitrate. So then you have to filter out so that the bacteria is removed and that bacteria will not eat up any of those pollutants or remove them from the system. So when you're looking for dissolved pollutants, you got to filter it, and you have to also check that the filter itself is not absorbing pollutants, because the filter should be neutral or inert, so that filtration itself is not changing the concentration of dissolved pollutants. But if you are looking for total concentrations, you should not filter, because total concentrations means particulates as well as dissolved. So when you're looking for TSS, total suspended solid, filtration is going to remove all of them. So that's why you don't want to do it. So these are the condition you should use for heavy metals. Most of the time you use acid wash plastic bottles. The reason you use plastic is because plastic itself do not bind with metals, or it do not, it may bind, but at least it doesn't dissolve. It doesn't have any residual metals as long as you clean it properly and acid washed it. But if you do the same thing for glass container, sometimes glass has impurity, it may have some metals. That's why for heavy metals, most of the time you use plastic bottles. For organic pollutants, you do not use plastic bottles. The reason is organic can bind with another organics. With plastic is organic carbon, so that means it can bind. So if you let's say you take in a plastic containers, these organic pollutant, if they are low concentration, they may start binding to the wall of the bottles. So by the time you take measurements, the concentration might have decreased. So a lot of times organic pollutants, you choose to use glass containers. So for instance, if you are measuring TOC or total organic carbon, use glass containers. But if you do use plastic container, which is a lot of times is easier, it doesn't break. So that's why people prefer it. You have to account for how much of those pollutant may have bound to the wall, and that way you can account for that. The last one is pathogens. Pathogens or FIV, you have to store them in a 4 degrees Celsius because the bacteria can multiply or die very quickly within hours. So that means when you collect these samples, you have to put a cooler. Inside the cooler, 4 degrees Celsius, you keep it, and within 6 hours, you have to measure the concentrations. So that's the sample handling. It's very important to think of what kind of container. So again, what you learn here is that for metals, mostly use plastic bottles. If you use TOC or organic, probably want to use glass container. And for pathogens, container type doesn't matter as long as clean, or it is being cleaned with a methanol or irradiation so that you have no bacteria there, and you have to store them quickly in 40 degrees Celsius so they don't multiply. Whether you pre-clean, how you pre-clean is based on the type of pollutant so that your they stay dissolved. And for volatile pollutants, you keep it in submerge, completely fill the bottles. Don't leave any headspace. Storage. So a lot of times you do not measure the pollutant concentration quickly because it takes time. You have to send to the lab. So how long you store it might have influence. For metal, you can store it for weeks because metal do not destroy it by itself. The only way metal concentration may decrease is a particular dissolved metal, so it can bind with the wall. So as long as you acidify, it will stay for a long time. So that's why acidification is needed. And again, for particulate pollutants, you have to measure quickly, or at least you have to make sure the resuspension happen as quickly as possible. So that means that anytime you take a stormwater pollutants, the particles settle. Before you measure the total concentration, make sure you shake well and mix them together so that the particulate become resuspended. Some pollutant concentration vary with time because of biodegradation. So that means the pathogen concentration, organic concentrations, and nutrient concentration will change with time because of their ability to interact with the microbial community in the water. So if you want to measure nutrient concentrations, you have to minimize the biological process or bioactivities. How do you do that? First, you could filter it so that all bacteria is removed. That way you can measure the dissolved concentrations. Or you could make the condition so acidic, like adding HCl, that bacteria will not grow. That means your nutrient is preserved. But mind you, always when you add acidify, use HCl. Do not add nitrate or nitric acid. Do not add nitric acid. The reason is nitric acid is a source of nitrate. So if you add nitric acid, that means you're adding nitrate. So always add a species that do not add to nutrients. For pathogens, store in cooler so that it do not grow or die, and analyze within 6 hours. For nutrients, you can store for many days as long as you remove the bacteria. Dissolve organic, again, same thing. Filter it, store it in refrigerator so that it degrade over time. And sometimes you have to keep in dark if it is basically degrade over time because interacting with the light. So this is something you have to check. For sediment, particle size aggregations, particle size or TSS, so this could change over time because of settling and aggregation. So that's why it's important to shake them and measure within certain days. Because if you keep it longer, then there are bacteria grows that could happen, and that could also add to the particulates. Biofilm will form all that. So it's important to measure this concentration of TSS very quickly. And these are very easy to measure. That's why it's important to do that as soon as possible. So that's the end of this particular video.